Welcome to Malware analysis for hedgehogs. This is the second part of our alpha ransomware video, and today we look at the unpacked alpha ransomware sample and also the clean version that we created using the E4 dot, so we have an easier time looking at the code. And yeah, let's just open that up in the nspy, I guess. That's here. And I still have this open from the last session, so this is the clean version of alpha. And we may just click on the entry point here, which is the main method. And then it says application run new form, so form is the next thing that's been opened. So here's the constructor of form 1, and there is an initialize component method in it. So let's take a look. And an event handler, the event handler will call or will be called if a certain event happens, which is maybe the loading of the form or something. So let's just click on that. So the next thing that will happen probably, and I would say this looks already interesting. This is obviously not a legit file, so it might be that the malware at some point copies itself into that location. Service host exe is a legit file, but it's not located here. We should look at this one. String 7 is add data. Can I rename that? That would be quite nice, actually. I think it would be helpful if I could rename just some certain variables and fields and so on. This. Yes, it's possible. So I say this is the app. Oh, let's stick with the conventions, I guess. App data folder. Okay. Nice. This will help us. If we encounter this string again, it will certainly help us with knowing what's happening in there. So here is we can do that for the other strings as well. Just edit this. That's the system drive. It's just called system drive folder. Okay, and here is a reference to an image on imgur.com. We may take a look at this one. And it's, well, that looks like it could be a wallpaper, maybe. It says encrypted, so we say encrypted image, something like that. We don't know what these are for, so let's go back to where we came from. So this is the app data folder and Windows and service host exe. So this is not legit. We already know that. And it checks if the file already exists. And if it doesn't exist, it will execute method 6 and method 5 and then return. So it will then go up here. And otherwise, it will execute method 6 and method 0. So there's a branch here. And here's a string that's being initialized, and the return value is method 1. So let's check this out. And it says something with processor ID. Okay, so it returns something with the processor ID, but then somehow merge into a string where this value is twice in there with a dash. So whatever that is, process ID dash process ID. Yeah, looks like it. So this method actually means return processor ID. So okay, can I do that here? Or something like get processor ID, get processor ID string, because it's not the process ID, it's a string with a dash. It's something kind of different. Try. Couldn't find the edited method. Okay, it doesn't work that way. I haven't tried it yet, so with the edit method stuff. So maybe I can edit the class, but I don't know if it edits the whole class then. Ah yeah, I think it said one. Yes. There are two edit method options. One will edit the code of the method and the other will edit the parameters and so on. So this should be better here. We say get processor ID string. It's somewhat a string. So, and it calls some other methods. So it's not just that. This isn't the result though. It's passed to method 12, which does something to it. Okay, it's not the processor ID we get. It's a hash of the processor ID dash processor ID. MD5. String 8 is what's been given to them, and string 8 is being put into the bytes array, and then the hash, the MD5 hash, is created from that. So I guess we can say it's somehow the MD5 hash, but then they do something else here with they just use a string builder to append all of the values in the array to create the string. Okay, so this is the get MD5 hash string. Okay, and let's go back and make this a bit more. Make this better. This is actually a get processor ID MD5 string, something like that. So that makes more sense, I guess. And if there's an exception, if we call method 0, whatever that it does, an exception will cause it to encrypt. That's interesting. Why would an exception do that? Are they expecting an exception? They will then... I mean, that looks like an encryption function, right? Because they are enumerating some drive information and files, and they check if the current file extension is .encrypt, and only if it's not .encrypt and not .ini, they do something to it, like setting attributes and then other method stuff. So it looks like this is a kind of encryption function here, which is confusing that they do it if there's an exception. But we saw this method 0 here in that case, right? So it's being called if service host.exe already exists. Then it's also being called here. Otherwise, the encryption function is not being called. So it could be that this malware only encrypts if it is already in this location, unless it's somewhat called in method 5 as well. So that's something we could test, or we could just check again what happens here. So let me rename this to encrypt files. Okay. So, and yeah, that's basically how you go about analyzing any malware. Once you have it unpacked, just renaming variables and methods and maybe also classes can work wonders. So same as if you analyze stuff in IDA, I recommend that you use the possibility to rename the subroutines to something that makes sense. The code will just, you will just have a much better understanding of the code instead of trying to remember this method 5, what did method 2, what did method 3. So this is really, really helpful. Don't underestimate it. Yeah. So it disables task manager in the registry. Let's just figure out a few functions here. Disable task manager. Okay. There's some timer stuff. And this will kill task manager if the process is there. Kill task manager. It's not much more. I mean, it starts this timer kind of. Okay, no. That's not where I wanted to go. Timer 1 is just, okay, so once in a while it will kill the task manager. And here's the ransom note. They apologize for the inconveniences. Well, how should we accept this apology if it's on purpose? Yes. And here is a more encoding stuff. So this might encrypt a single file, or this one, method 10 and method 11. I think we still have to check the context, but this looks like this is triple DS and this is AES. So maybe they use two different encryptions, and the set of extensions. Nice. Here is the service host.exe again, and that's the app data folder. So they use winlogon and the run entering the registry to persist the malware. So this is indeed a malware file, which is a copy, which we see here. The malware copies itself into this location. It sets the attributes to normal. Okay. I kind of was expecting they set it to hidden. They run themselves, and then yes, and then they set the value Microsoft for the run key. So they set okay, so I guess to make it look legit, they set the value Microsoft for the run key, which will auto run our malware file service host.exe. So this is, I would say, persist malware. Persist. Copy and persist. Copy and persist. Okay. the task manager stuff. Edit this, we say this is a kill task manager. Yeah. One disables it, one kills it. And this is also kill task manager every 5. I'm not sure if those are milliseconds or whatever. You would have to look up the documentation of the timer. So sometimes. Okay. That looks quite good already. So from the coverage, let's take a look at the, where are we actually? We are in the form 1, and now you can see which methods we already looked at, and there are a few more. Okay, so it will copy and persist. That's interesting because it will copy and persist here as well. So this is part of the encrypt files as well. So what it doesn't do, if this, it's indeed the case that if this file service-host.exe doesn't exist in the app data folder windows, it will not encrypt. So in order to make it encrypt, we might have to move our malware file into this folder or edit this stuff here. We can edit this. So, or just, can we change the path while debugging? It might be possible to do that. So this isn't clear, I think. For each string current, that's the current file, in form method something. So it gets a list of files using method 13. That's what I expect. That's a search option. Oh dear. I'm not quite sure what this is about. Enumerable. It's not that important though. Okay, let's check this out. So it somehow gets files. Search option, all directories, drive info name, and this one, searching for all files that have any extension and any name. And so it calls method 8 with the current file and this string. Now we need to figure out what this string is. And it's calling method 11 with string 6 of the form. We don't know where this string comes from. So now you can right click and analyze. And so to see where this is being assigned, it's in the load. And that's the process ID. So we should rename this field to MD5 of the process ID. Processor ID MD5. Alright. So now we know it's using that. And this is the same. This is passed to method 11. And method 11 is this triple D as encryption stuff. Yes. Encrypt with triple DS. So it returns the part as a string in base 64. And so we have the MD5 it gets the process ID, it creates an MD5 of the process ID dash process ID, it encrypts this with SSS and then puts this into a base 64 string, and that's what the result is. That's somewhat the processor ID stuff. And it's a local variable. I would like to edit it. I don't know if this is possible. We don't see a possibility to do that here. So, okay, but a triple DS stuff. And then it's been calling method 9 and method 16 on the desktop, on my pictures, on cookies. I assume these are the folders where it specifically wants to encrypt the files, and it sets an environment variable new style JPEG. Let's try to figure out what this is. So if it passes process ID, yes, that's searching for files with these extensions. That's a list of extensions it wants to encrypt, and it gets the files, gets the directories, gets the extensions, and so on, and calls method 8 if the extension is in the list. So let's say encrypt folder to this one, added method encrypt folder, and that was the, can I edit this? Maybe I can edit this in the edit method part, and I say edit. Yes, it works. So this is the, oh well, we don't know if they might use it again with another value. We don't really know what this is doing. Get files of string 8. So that's a folder. That's a directory. String 8 is the directory path. Oh. Okay, then we know. So we say params string 8 added, and that's the folder path, directory path, folder path. Okay. And now it will get all files in that folder and call method 8 on it, and if it's a folder, it will call encrypt folder on it. So it's recursive calling itself on the folder if it's a folder. Otherwise method 8. So this is probably encrypt file, which would make most sense. Encrypt file, and on string 9 is being used for them. So here, yes, string 8 is a file, and string 9 was this triple DS encrypted something process ID. So, and this is being used as a key here, and that was a file. Okay, we added the method and say this is the file to encrypt. Okay, and this is somewhat a key string. So okay, now we can see this much more clearly. It will get the attributes. Now this, you might be confused about this. This is a comparison if the file attributes are read-only, and this is a comparison if the file attributes are hidden. And this part will just edit out from those, from all attributes. It will make sure that only the read-only one part is returned. Because those are flags, and if you use a logical AND, you make sure only if it matches read-only, it will be there. So I'm not sure if my instructions are clear, but yeah, so it's comparing this, whether it's read-only and whether it's or if it is hidden, and if one of that is the case, it will set the attributes to normal. So it doesn't want the files to be read-only or hidden. And then it excludes the ransom node from encryption, which is an intelligent move. I mean, there is actual ransomware that does a mistake of encrypting their own ransom node. So, good thing to do that. And then I will read the whole file into the byte array. So if you have a pretty big file, all of that will be in your memory. Not a good idea. We get the bytes of this key string and compute the hash, the SHA-256 hash of that. And we say method 10 for byte for the file. So this will probably actually encrypt this. We should rename this to let's say set file attributes and encrypt file. Yes, looks awful, I know, but you need to know what it does. And this is the encrypt file stuff. So encrypt file. And yeah, and then it appends the encrypt extension. So let's go to this part. And we know, go back. We know the first one is the file contents and the second one is the key. So here we see a static salt. We see that the key is being used here, and it's AES that's being used here with key size 256 and block size 128. CBC. Okay. What does that mean for us? It means this the key of this ransomware is one we can generate. So the key is different on every system and it depends on the processor ID. So, and if we just do the same stuff, we can generate the key as well and just use the very same, well, not the very same, we need to decrypt it, of course, instead of encrypt it, but we use the same algorithm to decrypt it with the key. So this is quite possible to decrypt this ransomware encrypted files. So nice. We spent already 30 minutes on this, on just analyzing the ransomware, so I will stop at this point and we will do the decryption part in the next part. So there will be a third part, I hope so. Thanks for watching and see you next time.